Welcome to solverfy.
Okay, so I see that you need help with this question, and it says the following data come from a study designed to investigate drinking problems among college students. In 1983, a group of students were asked whether they had driven an automobile while drinking. In 1987, after the legal drinking age was raised, a different group of college students were asked the same question. So 1987, the legal drinking age was raised. So legal drinking age was raised. So use the square test to evaluate the null hypothesis that the population proportions of students who drive while drinking are the same in the 2 calendar years. So for 1983 and from 1987, we can say that they are dependent on one another because my expected value, just go back. So here's my actual values. These are my actual. And then for my expected values, okay, for the yes is 1,116.27. And for 1987, it's 1,124.73. This is for the yeses. And for the no's, it is 1,520.73. And then 1,532.27. Which means that my chi square values is for my yeses. I'm just going to follow the same. No, 1983, 1987. So for my yes, chi square values, it's 16.02 and then 15.9. And then for no's, 11.76 and then 11.67. So see how close they are. So my chi square is equal to 55.3553. And my p-value is less than 0.0001. Oh, there's 4 zeros there, sorry. And the result is significant at p is less than 0.05. So this means that they are dependent variables. So what I can conclude about the behavior of college students, so we can say that they are dependent. Again, test the null hypothesis. What proportions of students who drove while drinking are identical for the 2 calendar years? This time, use the method based on normal approximation to the binomial distribution, which was presented in 14.6. Do you reach the same conclusion? So if I go 1250 out of 2,637, I'm going to get 0.47. And then 991 divided by 2,657 is 0.37. So if I do a 95% confidence interval for the true difference of population proportions, this is D, okay, I'm going to take 0.1 because that's the difference between the two, plus or minus 1.96 times the square root of 0.47 times 0.53 divided by 2,637 plus 0.37 times 0.63 divided by 2,657. So then I have 0.1 plus or minus 1.96 times the square root of, or actually, let's skip a step. So then you're going to get 0.026. And my confidence interval is going to be between 0.075, comma, and then 0.13. That's if I go out to 2 or 3 decimal places. So for answering E, does the 95% confidence contain the value of 0? Would you have expected that it would? So with it being dependent, yes. So 95% confidence interval does not contain 0. So there is a difference between the two. So I hope that this video helps. This is a middle school math teacher signing out.